Identify the highest common factors, HCF, and fully factorize the following expressions. So 14x to the power of 4, y plus 42 to the power of x cubed, y squared minus 49 x squared y. Okay, so the question says, identify the highest common factor, HCF, and fully factorize the following expression. So in this question it says working is not required for this section, however I will show the working. So the very first thing what we have to do is to deal with the whole numbers first, and then we will do with the algebraic terms, parts of the term, later on. So let's take the whole numbers. So we'll take the 14. So we write down the 3, in this case the 3 whole numbers. So we'll deal with these first. And before we do anything, whether we're finding the highest common factor or the lowest common multiple, the first step we have to do every time is to find the prime factors of each of the numbers that we're given. So with the 14, the 42 and the 49. So starting with the lowest prime numbers, we ignore 1. So the next lowest prime number is 2. So what we do is we take the prime number, in this case 2, and we know that 2 goes into 14 7 times. So we write down the 2 numbers that we get, and these 2 numbers in this case are both prime numbers. And sometimes it's quite helpful just to highlight them, just so that when we achieve a prime number we can just put a little mark around them as well. Okay, and then we do that for the next number, starting with the 2. We know 2 goes into 42 21 times. Okay, so we can't do anything more with the 2, so we do the same now. Because 21 isn't a prime number, we know that 21 is divisible by 3 and 7. But if unsure, just start it with the test. Start with the lowest prime number. Well, we know 2 can't go into 21. However, 3 will. So 3 will go into 21. And 3 goes into 21 7 times. So we end up with, just put those little lines in just to show what we mean. Now we end up with, we have a 2. We have a 3. And we have a 7. And there's nothing more we can do with that. Going down to our third number, does the test, does 2 go into 49? No, it doesn't. 3, does 3 go into 49? No, I don't think that does either as well. So the lowest prime number that will actually go into 49 is 7. And we know that there are 7 7s in 49. So we've now completed that task as well. And we have now 7 and 7 there. What we now do is we write down below what the actual are. In this case it's 2 and 7, so we write 2 times 7. In this case we've got 2 times 3 times 7, and here we have 7 times 7, which we know is 7 squared. Now you can write it individually like this, or you can, if you've got more than one instance of the number, in this case we've got 2 7s, you can write it as it's with its indice. Now we need to find the question says to find the HCF. So let's just finish this problem off. So the HCF, and what we do, and you can do it this way, there's many ways you can do it. This is the sort of long way, but I'm going to write in the 3 numerical terms, or numerical parts of the term, down below. And you can do it a number of ways. This is just opening things up. So we start with the 14, and what we're trying to do is to line up all the common terms in columns. So I'll start with the 2's. So we know 14's got a factor of 2. We know 42 has a factor of 2, so we'll put that underneath there to line it up. There are no 2's in 49, so we ignore that section, that column now. So the next lowest one is the 3, which we know only occurs in the 42. And the last factors are 7's. So 14 has got a factor. Now it's important that you don't put different factors in the different columns. So whenever there's a new factor, start a new column. And doing it this way, you start off with the smallest factors on the left and the biggest factors on the right, and this is the way to do it. So we have a 7 in there. 42 also has a 7, and 49 has 2 7's, so we write the 7 in there and we write the 7 in there. Almost done. I'm just changing my pen to red. So to find the highest common factor, what we must do is we look along the columns and we look for any number that is present in all 3 rows. 2 and 2 is only present in 14 and 42, so that isn't much use. Again, the same as 3 is only present in 42 here. However, we've got a single instance of 7 in all 3. But what we're going to do now is we're going to group those together like that. And this gives us our HCF. So our HCF is 7, because 7 is common. And if we look along all through here, we can see that 7 is common to 14, 42 and 49. And the HCF is the biggest number that will divide equally into all the 3 numbers in the terms. So the biggest number, it can't be any bigger than 7, because if it was bigger than 7 it wouldn't divide into 14. So that's the biggest number for 14. So therefore it has to be common with all the rest. Yes, we can have 7 times 7 in 49, but it's not common to 14 and 42. So therefore the single instance of 7 is the common element. And that is how we find the highest common factor. Now to find the highest common factor of the algebraic sections, it's a lot simpler, because really if we actually look at these are already factorized for us. Because what we've got is we're saying x to the 4 is x times x times x times x. X to the 3 is x times x times x. And x to the 2 is x times x. So we can see straight away from the x terms that the highest common factor is x times x, or x squared, because it's the highest value that will divide into all 3 terms. Now we can actually put these into our table as well. We'll now do the algebraic terms for 14 is x, 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 and x. We'll do the same for 42, which case is x cubed. So 42, and again make sure you keep everything lined up. X times x times x. And finally in 49 we've got x squared. So we have x times x. And it's as simple as that. Now let's do for the y terms. We've got y in 14, so we put the y there. The y squared is in 42, so we put a y and a y. And a y cubed in 49, so we put y cubed in there, which is y times times y times times y. And let's now find the highest common factors. So how did we find the highest common factors before? Well, what we did was we looked along the columns and we looked for a common instance of a number that was present in all 3 rows in this case. So in this case, let's do the same with the x. Let's make our group, or we know now, we have like a group that big now. And let's move on to the y's. We have group 1, 2, 3 there, which is good. Our y's are only a single instance. The common element here is x squared, or x times x. and the common element here is y. So we can now write our full HCF, and what we do to write the HCF, we put in the numbers to the left hand side. So our HCF, and we found before that our numbers were 7, and the algebraic terms rather were x squared and y, and that is how we find the HCF of a set of terms. The next stage of the process is to factorize. So to factorize, we write down the HCF, 7x squared y, and then we open up a set of brackets and we divide 7x squared y into 14x to the power of 4y. Now, if you remember the rule of indices, the algebraic part of it is relatively easy. But like everything else, we can deal with the number part of the term separately from the alphanumeric, which is great. So first thing to do is take the 7. We know 7 goes into 14 2 times, as we found here. So the first thing to do is our numerical term is going to be 2. So 2 times 7 is 14. And we divide x squared y into x to the power of 4 and y. Well, we know quite simply from our rule of indices, if we're dividing, let's do this up here. If we divide x to the 4 by x to the 2, or x squared, the rule of indices says when we're dividing, we subtract the indices. So in this case, what we're actually doing is we're just saying 4 minus 2, which equals 2. So x to the power of 4 divided by x to the power of 2 equals 2. So to finish this off, so now we can say x squared into x to the 4 is x squared. And we do the same with y. Y goes into itself once, so we don't write anything in there. We can prove this in a minute. So our next term is added. So 42, 7s into 42 is 6. So 6 times 7 gives us 42. And x cubed divided by x squared is, remember, 3 minus 2, which gives us x to the 1. We don't write the 1 in as an indice. So that is just simply 6x. And y goes into y squared. This becomes y. And finally, the third term is subtracting, so we put the subtraction symbol in. 7 goes into 49 7 times, so that gives us 7. And the x squared this time divided by x squared goes into its self once, so we don't need to write that in. And y cubed divided by y, 3 minus 1, gives us y squared. And then we've got nothing else to do, so we close the bracket. And this now gives us the fully factorized expression. If you wanted to prove this was correct, with all this work that we've done, then you'd need to expand the brackets, and expanding the brackets should take us back to our original series of expressions.